Okay, so this is week 6, term 3 for grade 9. We are looking for the incorrect answers here. So please note we are talking about the noble gases. They are inert. Inert means unreactive. They don't react. We'll see later why. But this is correct information. We are not looking for the correct. We are looking for the incorrect. Their melting points and boiling points decrease down the group. No, they don't decrease down the group. They increase down the group. As you go down in the group 7, the melting point and boiling point increase. So this is wrong. This is that's why we choose it. We are choosing the wrong ones. They are highly reactive. No, they are not reactive. They are unreactive. They exist initially in monoatomic state. That's correct. Yes, they are existing as monoatomic. So if you look at the drawing of the noble gases, like if you make neon, you'll see what every neon atom is separate, not together with another atom. And if you like krypton, there is another noble gas. They are all monoatomic. This is different from something diatomic. Like if we are looking at nitrogen, for example, if we are looking at nitrogen, you'll see it's made from two atoms joined together. It's diatomic, always two atoms working together. So this is nitrogen, N2, this is N2, they are N2, N2. Here, if I looked at neon, it is alone. Let's make it alone. So if you looked at xenon or if you look at radon, if you looking, every one of them is separate. So everyone is radon, for example, or let's say krypton. So krypton, so this one is separate. While if you looked at oxygen here, every two oxygens are together also with diatomic. What are diatomics? They are every two atoms are together N2O2 Cl2 F2Pr2. So this means that it is correct. So we don't choose it. It's from group 8. Yes, of course, it's from group 8. Let's see the next question. Talking about the group 1 elements, we said that there are two types of metals, the strong metals and the soft ones. The strong metals are the ones which has high melting point and boiling point. They are strong and hard to cut. This is known as the transition metals. So the transition metals, we'll talk about it in the next questions. Transition metals are the strong ones. The weak ones means it has the boiling point and melting point is high, but not as high as that of the transition metals. And their boiling point and melting point are low numbers. They are very soft. You can even cut it with a knife. So you bring a piece of sodium and cut it with a knife, which means that it is very soft. They react violently with Cl2 to produce white solids. So if you Cl2 reacted with the potassium, it will make KCl. Don't forget to balance this one. So it is case. Also, the sodium reacts with Cl2 to form NaCl. This is violent reactions, explosive reactions, or mixed exothermic reactions. There is heat coming, there is fizzing. So 2NaCl again. They are all shiny when kept underwater. No, they are shiny when kept, but not underwater. So if you want to protect them, so put them under oil like kerosene. So this is your metal. You have a piece of metal of potassium, for example, and want to show it to your friends. Don't put air here. If you open it to the air, it will react and it will become dull. So it will react, it will become potassium oxide. So don't put it on air. You have to protect it. So what you protect it with, you bring a layer of kerosene. This is a type of oil that you will take later. This is kerosene oil. So put the kerosene here, and this will protect it. So don't put it under water because it reacts very violently with water. So violently, so potassium with water forms potassium hydroxide. This is a violent reaction. We don't want it to react. We want to protect it. So we don't react it with water. We don't keep it under water, we keep it under kerosene. They all react vigorously with water to produce hydrogen gas, so KOH and H2 gas will be produced. Now let's have a look at the examples of gaseous elements at the periodic table. In the periodic table, I have three types of elements. I have at the room temperature, at the room temperature, when the temperature is not that high, it's like 20 degrees centigrade, the elements can be either gases or can be either solids or be liquids. Let's see first. Remember, we are talking about room temperature only. This is at 20 degrees centigrade. You can be a liquid. There are two elements only which are liquid at room temperature, the mercury and the bromine. The mercury and the bromine, you know the thermometer has some mercury, it's always liquid. And this is Hg, the symbol of it. You must know it because sometimes he will not mention the name, he will mention the letter. So Hg is mercury. And the bromine, Br, this is also diatomic, always available as Br2. Remember, anything which is mono is diatomic. Don't write it as diatomic in the periodic table. We write it only as the element, but only when you write it in a chemical equation, it becomes diatomic. So these are the two elements only two which are liquid at room temperature. What about the gases? There are 11 elements which are available as gases. So it's easy to remember them because already 6 out of the 11 elements are noble gases. So 6 noble gases. Where do you find them? You find them in group number 8 or 18. So this is group 8 or 18. You find the noble gases. So it is helium, and then neon, and then argon, and then krypton, and then xenon, and then radon. So 1, 2, 3, 4, 5, 6. Now there is also hydrogen. So I have also hydrogen. I have nitrogen with N, and oxygen, and fluorine, and chlorine. 1, 2, 3, 4, 5, and 6. So total is 11 gases at room temperature. So only 2 as liquids, mercury and bromine, and 11 as gases, and the rest of all elements are solid. You see all this in black are solid. So this one is liquid, this one is liquid, mercury and bromine, and the rest are all either gases, but the black are all solids. So most of the elements in the periodic table are solids, only 2 are liquids, and 11 are gases. That's why in our question here, I will choose fluorine. This is fluorine, F2, one of the 11 ones that we said they are gases. 6 only are noble gases, the rest are gases, but not noble gases. When you write them, you said that you write them as H2, N2, O2, F2, and Cl2 because they are what? They are diatomic. This one is not diatomic, this one is monoatomic. So the noble gases are monoatomic. Remember, we said this is monoatomic here in the first question. They are monoatomic state. Here the non-noble gases are diatomic. The next question is asking about metals properties. The metal properties, they are shiny, they are ductile. Shiny means that they have shiny color. As you see, when you go and buy a car, you tell them, I want a metallic color. So this is a shiny color, and they are ductile. They are electric conductors, they are electrical conductors, and they are also something called malleable. What is the difference between malleable and ductile? Malleable means I can change the shape. So I can have a block of iron and change the block of iron and make a different shape from it. I can change it into a shape of a car or make any type of bars or steel. The ductile is that I can change my block and make it as wires or sheets. I have copper, for example, this copper element, I can change and make copper wires from it, or I can make sheets from it. This is properties of the metals, and you need to memorize them. And next question, elements between group 2 and 13 are called what? They are called the transition elements. So if you look at the periodic, so have a look at this one. They are the transition metals between group 2 and group 13. This is between 2 and 13. These are the transition metals. Transition metals, we said they are the strong metals. They have some properties. They form colored compounds. So most of the compounds that's made with these transition elements have colors. Even in the fireworks, you see as in the New Year's Eve, you'll see rockets which are having some metals which make them get these colors. What about the other properties? They have more than one charge. So if Fe, it can be +2, it can be +3. The chromium can be +2, can be +3, can be +5, can be +7. But only for the the ions which are not from the transition. Like for example, I have sodium. What about it's positive, only positive, and Cl is only negative, so it's only one number, but this one has multiple numbers. So they have more than one charged ion. They form colored compounds, and they are between group 2 and 13. We also have the alkaline earth metals, which is in group 2, and the alkaline metals. So take care between the difference in the names. This is alkaline earth metals and alkaline metals. So alkaline metals is in group number 1, and alkaline earth metals is in group number 2. And then I have also the noble gases. So I have also the noble gases. So again, this is the alkaline metals. This is the alkaline earth metals. This is the noble gases. So these are noble gases, and the end in group 18. And you can see that there is metals and nonmetals. So there is like an imaginary line, imaginary ladder here in the periodic table. Whatever is on the right are non-metals, and whatever on the left are metals. So here that's on the left are metals. These are the metals, and this is the non-metals on the right side. If you see that most of the elements in the periodic table are solids, and most of them are metals. So the metals are always solids, except here in the mercury. This mercury is blue, which means that it is liquid. We said there's two liquids, but the non-metals are either gases or liquids. Most of them are gases, except this bromine is liquid, and I have phosphorus and sulfur and selenium and iodine. This is solid. So the non-metals are always either gases, the 11 ones that we took, or they are bromine liquid, they are liquids like the bromine, or they are solids, in this case the phosphorus, the selenium, the sulfur, the iodine, that are in the form of solids. These are all solids. What about the metals? The metals are all solids except the mercury. So the metals are all solid except the mercury, which is liquid, as we agreed. There is no gases, of course, in the metals. The sodium chloride is a very stable ionic crystal because it's built of charged particles that have electronic configuration of noble gas, and we'll explain this in the next video.